Okay, in this question we are asked to solve the equation for x. The first thing that we should notice is that this equation does have a radical in it. It has a square root, and there's one of them. And the procedure for solving an equation with one square root in it is to get that square root by itself. So let's go ahead and do that by adding 3 to both sides, which allows us to get the square root of 6x plus 13 by itself, and that equals x plus 3. Now in our next step, we're going to go ahead and square both sides of this equation. Squaring is the inverse of the square root, so that gets the 6x plus 13 by itself. Now on the other side of the equation, we have to be careful to actually square the binomial by writing it out and doing the full distributing of all parts. So 6x plus 13, and if we distribute or FOIL, whatever's your method, x and x would give us, or x times x would be x squared. X times 3 would be 3x. There'd be another 3x by multiplying that 3 times that x, giving us a total of 6x. And then finally 3 times 3 is 9. Okay, so we no longer have a radical. Now we need to pause and just ask ourselves, well, what do we do with this? Well, this ends up being a quadratic. We've got an x squared there, so we're going to have to solve this in terms of a quadratic. Now, the first thing that I notice is that we have a 6x on both sides. So if we subtract 6x from both sides, we won't have any x's on either side, because we'll get 6x minus 6x, which is 0. So we'll just have 13 equals x squared plus 9. Now, in the same step here, just to save a little room, I'm going to subtract 9 from both sides also. So when this is all said and done, I'll have 0 and 4, so 0 plus 4 is 4. And over on the other side, I'll have x squared plus 0, which is just x squared. This is nice. This quadratic can be solved by square rooting. So I can just go ahead and take the square root of both sides, remembering that when I do so, I need to introduce a plus or minus, because that square root of 4 could either be 2 or negative 2. So x equals 2 or negative 2. Now, this problem was nice. They gave me a little warning that I need to check for extraneous roots. Whenever you have a square root and you're squaring both sides, there's a possibility that even if you did everything right, that one of these answers doesn't work in the original. So if I just kind of talk through this, 6 times a positive 2 would be 12. 12 plus 13 would be 25. The square root of 25 would be 5. 5 plus a negative 3 would be 2. And I'm using an x value of 2, so that works. If I try out negative 2 times 6 is negative 12. Negative 12 plus 13 is 1. The square root of 1 is 1. 1 plus negative 3 is negative 2. And that equals the x value of negative 2 that I'm using. So actually both of these answers are fine, and we don't have any extraneous roots in this situation. So that's solving equations with one radical